Okay, so from the flow chart, we are really filling a lot of gaps. We know what a GCF is and how to factor. We know how to factor trinomials of degree 2. You can either use the AC method or the guess and check. And then there's the grouping of 4 or more terms. And then the last one was patterns. Patterns are usually used when we have something involving 2 terms. And so you'll notice the 4 polynomials I have here all are binomials. So there's only 2 terms. So they got to fit a pattern. And the second thing, before we get into this discussions pattern, I'm actually going to treat section 5.4 and 5.5 as one. Both of them are regards to patterns. There's 3 overall patterns. And so I'm just going to treat this in one thing rather than breaking up into 2. So one quiz for 2. Just kind of shorten things up. So in 5.4, what we're going to consider is the pattern of the difference of squares. Now if you go back to chapter 4, here's what we found. To create the difference of squares, I have to have the same 2 terms and add them, and I have to take the same 2 terms and subtract them. And when I do that, right, FOIL it out, a times a is a squared. The outer gives us a negative ab. The inner gives us a positive ab. And the last gives us a negative b squared. The outer and the inner cancel out, leaving us with the a squared minus b squared. So in order to, this was multiplication. What we're doing is going in reverse. We're starting with a pattern that looks like the difference of squares, right? We're subtracting 2 things that are being squared, and the factorization is sitting right there. Base plus base, base minus base. So to use this pattern, first of all, we have to see it, and then we got to figure out, well, who's A and who's B, and then we just basically, it's like a formula, you just plug it in. So this first one, we obviously have a difference, right? This is being squared, and if we think about it, 49 is 7 squared. So this is your A and this is your B. So the pattern says we take our bases and, we take our bases and we add them, and we take our bases and we subtract them. So how do we factor x squared minus 49? We factored it as x plus 7, x minus 7. Of course, how do you check? FOIL it out and see that it's true, right? First times first is x squared. Last times last is negative 49. The outer is a negative 7x. The inner is a positive 7x. They cancel out. So it works, right? And so we're using a pattern. We're seeing the pattern and using the pattern. So the next one, I do have a difference. I do have a square. So can I write these 2 things as something squared, right? What are the bases, basically? So right here, the base is actually 2x, right? So 2x squared results in 4x squared. Minus, well, 3, we know that to be 3 squared. So here's your A and here's your B, right? That's a 3. So basically, we truly have the difference of 2 squares. So what's the pattern? We take the bases and we add them. We take the bases and we subtract them. So we get 2x plus 3, 2x minus 3, and there's your product. We're finished. Move on, next problem. I'll let you guys check that at home by filling it out. Moving forward, right, we have 16x squared minus 25, so it's a minus, a difference. It looks like something that's being squared. So what I'll do here is try to figure out, well, what exactly is being squared there, and that's a 4x. And this second term is a 5. So I truly have the difference of 2 squares. This is playing the role of A, and that's playing the role of B. So what's the pattern say? We add the bases, subtract the bases. So we have 4x plus 5, 4x minus 5, and there is our factorization. All right, so we're rolling. I'm trying to make this harder. Let me throw some fractions at you. Again, we do have a difference, and we do see a square. We just need to figure out, well, what term's being squared? Well, 1/9 is 1/3 times x, and we're squaring it. 4 over 25, well, that would be the fraction 2/5 being squared. So I can see I truly have the difference of 2 squares. And so here's my A and here's my B. And so the pattern says add the bases, subtract the bases. So we get 1/3 x plus 2/5 and 1/3 x minus 2/5. And there we go. So basically we've been able to factor 4 polynomials pretty quick because we were able to recognize the pattern. We were able to fit the pattern, right? Actually fit who's A and who's B, and then just plug them into our formula. All right, let me do a fifth example. You have to be really careful here, all right, because if you don't have something that fits, you don't have something that fits. All right, so let's just say we had 6x squared minus 25. I see it having two terms, so I'm trying to fit this pattern because there's a difference and I see a square. Now obviously flat 25 is 5 squared, so that's good. But this guy right there, right, that's really not a number that's nice squared. So this one is a little questionable, right? X is obviously squared, but 6, you know, that's not like 9 or 4 or 25. 6 doesn't have a very nice square. So since I'm not able to make this fit, this is another example of a prime polynomial. There's no GCF, right? The number of terms are 2, and it doesn't fit the pattern that is needed, right? So we've exhausted everything that can happen, so that would be an example of a prime number. So again, the pattern has to fit in order to use it. If it doesn't fit, you can't use it, all right? So for the first 4, it fit the pattern. For number 5, we couldn't make it fit, so it's prime. So there's your introduction to our first pattern, the difference of squares. We'll jump into 5.5 and I'll show you 2 more patterns to factor.